So, recursion in a programming language concept is this. So, recursive program is a programming method to handle the repeating items, repeating problems in a self-similar way. Self-similar way means that it's about itself. To solve a certain function, we have to look at that function, but in a similar, means that in a reduced scale. So that's the repeating recursion, and that's the concept of the repeating problems with reducing parameter size. If the parameter does not reduce, what happens? Actually, it explodes, right? When we solve the problem gets bigger. When we solve the problem gets bigger. Then it's getting much harder. Then it's better not to apply that approach. Means, right? So it's only applicable when we are handling the same problem in the reduced size, like this. So this is self-similar feature, right? So there is this feature, and this noun is handling like this cereal and then a cup of coffee or something. And actually within the feature there is another noun, and within the feature there is another noun. It's a self-similar way in the reduced size. How to form this, how to program this, code this in the MATLAB programs or programming languages, like this. So this is a pseudocode of this recursion example, often in a format of calling a function within the function. So when you define a function, within the function you have the same name. So you are going to define function A. Within that function A, you are using that function A with a slightly modified parameter set. And one another thing, there is a kick. Whenever you are at a certain condition, the kick hits, and then you are going to return it. And return means that you are escaping the function, and means that you are going upper layer of this function course. So this key characteristic is that target is going to be bigger than the target prime, because that is reducing size of the parameters, right? So analogy to this Inception, the movie, is that dream itself is the function, right? It's the function, and going to sleep or going to bed, it means that this function calls, all right? And this kick, if you want to try to get out of this dream layer, you want to meet kick, and that's this escape routine. And this totem is going to be the depth of the function. Usually it's being transferred, or the parameter passed to another dream layer through these parameters, right? So that's the totem, and what that is that usually is here and there, the parameters are included, right? So the totems tell only either 0 or 1 plus the abscess in the movie, but in the recursion, these totems is very likely to tell you the depth of the dream. So another example to explain about the recursion is a Fibonacci sequence. So have you ever heard about the Fibonacci sequence? It's like this. If you want to calculate the let's just write down the sequence itself. It's 0, 1, 1, 2, 3, 5, 8. Next one, guess. Just pause it for the time being, and let's get. Yeah, 13 actually is here. It's here. So if you were just good at noticing something, then you might be able to find out. So this is n equals 0, n equals 1, n equals 2, and n equals 3, and n equals 4, n equals 5, n equals 6, and so forth, right? Like this. Ding, 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 ding. And that's the Fibonacci sequence, and this is n, right? And what you want to do is calculating this Fibonacci sequence. There is a repeating problem here. So for the first two, n0 and n1, we are going to just define it. Of course, later we are going to use this as what? Kicks, right? And then actually this 1 is sum of the 0 point plus 1, and this is 1 plus 1, this is 1 plus 2, and this is what? 2 plus 3, and this is 3 plus 5, and this is 5 plus 8, right? So it means that this is sum of this and this, right? This is sum of this and this, right? And this is sum of this and this, right? And so forth. So there is a repeating problem, of course, and that's adding something before one step and before two steps, right? So we can represent the Fibonacci sequence as a whole, like 0, 1, and Fibonacci n minus 1 plus Fibonacci n minus 2. And that's how we can represent the Fibonacci sequence in the repeating problem concept. And if you are going to program this as a MATLAB programs, actually this is the programming, all right? So we have these Fibonacci functions, and if n is equal 1, and out is just 0, n is equal to, and out is just 1, and actually this is going to be 1 and 2 and 3. In this concept, it's just an indexing problem. So, and after that, if it is not 1, if it is not 2, then we are going to just adding up just two numbers, right? And when we hit here, we are going to call the Fibonacci function again. And then we get the numbers, and we have a certain number here, right? And then we have this number, right? And we have certain numbers here. Like, it's going to be called this function again, right? So by adding these two, then we are going to return it, right? Then to compute the F4 Fibonacci number 4, how to do that? So let's find it out. So F4 is going to travel right through here, and it's going to call F3 and F2 by hitting here and here, right? And after hitting here and here, then it's going to go here, and 3 will go here, and it's going to call 2 and 1, right? And F4 is going to call the within the F3 there is a moment. Let's start from this explanation by writing it down. F4 plus F3, and we have to F3, F2, right? Sorry, I'm going to erase this. And write this F3 and plus F2, right? At this layer, we are going to call F3 and F2. And when we hit F3 here, then it's going to automatically call another function here, which will go read to here, program to here. And by following these lines, there will be moment calling F3 plus F2 plus F1, right? And whenever we call F2 here, and then it will lead to here, right? Then there will be moment calling F2 to F1 and F0. I'm following this indexing here, and this F1 is going to have a certain number equals 1, right? And F0 is going to have a certain number called 0, right? And then these if routines will be activated, and then this number 1 and number 0 will be returned, right? Returned. And then by adding up, right? By adding up, it's going to be 1, and this 1 will be returned. And to calculate this, we have another function called to the F1, right? F1. And F1 is just 1, right? And then it will return. So 1 plus 1, right? So it's going to be 2. And 2 will be returned. And this part is going to be completed. And then F2 is that F2 will call what? F1 plus F0, right? F1 and F0. And in the F1 case, it will going to be 1 and return it, and then it's going to be 1, right? And then F0 is going to be what? It's going to be 0, and then return it, so it's going to be 0. So it's going to be 1, and when we return it, it's going to be 2 plus 1, so it's going to be 3, right? So it's going to be 3. So to solve this F4 problem, we have to navigate through what? These passes. I'm going to erase it for your just information. The same color. All right, that's how we navigate through by just calling F4. So we just called F4. Whenever we called F4, it's going to hit F3 plus F2. But before we reach to the F2 portion, we have to solve this F3. So this program will flow to the F3, and F3 to the F2, F to the F1. And there is a kick happens here, right? And after hitting kick, and F2 goes to the F0, and there is a kick, right? And then it will return 1, and it will call F1 again. And then it hits again the kick, and then it adds up to the 2, and it returns 2, right? And then you have to calculate F2 here at this portion, and you have to call the F1 and F0. These are all kick, right? And then this is going to be 1, and 1 is going to be returned, and this is going to be 3. So program, actually, even though we are just calling F4, the program flows from F4 through this F3, F2, F1, and F0, and this way, and after hitting all these function calls, then finally you get the F4 concept, F4 numbers, right? So that's how the recursive program, whenever we write the same function name within inside of that function, that's what happens. Luckily, we are very lucky to have this reducing parameter size. So there is a guarantee that at the end of the day, it's going to hit one of these kicks, right? And then there is a return, right? But without that kick, it's going to run forever. But when we are able to hit this kick, escape routine, then we are going to repeat the problems again and again, of course, with a slightly different parameters to compute a bigger problem, right? So that's the recursive program. So let's find a more mechanical concept. And actually, there is a concept called stack frame. Whenever you call a certain function, there is a big stack within inside of our computer in the MATLAB system, in the big stack, and that stack adds up that function calls, right? So you remember that stack, right? You remember the pop function or push function and so forth. It's going to be push. So how to do that? We have this stack, right? We have this stack. And whenever we call F4, it will remember that a certain parameter n was 4 and return address where it was called. This stack frame will remember these three things. And then in the F4 there is a function called F3, right? And it will add up F3, and we are at this level, right? And F3 we have a chance to call F2 and then push, right? And we have this F2 and what's 2 and return address is where, right? Return address means where it was called, right? And F2 and F1. And of course, this function ends very quickly because it's just 1, right? And return the 1 to a certain address, which was in the below. And we have F1 equals 1 plus now we have to call F0, right? And then we have another stack frame, another item in the stack frame, and n is 0 and return address. And it's going to be 0 and return it to here, and then it's going to be gone, and it's going to be what is going to be 1 and return it to the here, return it to 1, and then it's going to be 1, right? And 1 plus 1 and it's return it to 2. But however, it doesn't end because now we have to do F2, right? So we have another stack pushing and popping. And after we have done that, 2 plus 1 is the final answer at the N4, and it's 3, and this is 3, and it returns to somewhere else. And that's the end of this stack frame, right? So that's how we can find out how these things are computed, right?